Good day, I am Pascual Montes and today I present the hybrid intelligent method, evolutionary strategies and type-1 singleton fuzzy logic system to solve the open vehicle routing problem. Introduction. One of the famous NP-complete or NP-hard problem is the vehicle routing problem, also known as a TSP or tribal salesman problem. In fact, the NP-hard problems provide several solutions be combinatorial and then needs to be optimized. History. The first approach of VRP was made by Dancing and Ramser in 1959. Later appeared new approaches such as Open VRP, Capacitated VRP, VRP with time windows, Stochastic VRP, Pickup and Delivery VRP, Multi-depot VRP, among others. A survey in Google Academy in 2018 showed the following numbers. 65,200 papers contain VRP phrase. Also, 58,500 papers contain vehicle routing problem, but only 790 papers contain OVRP, and 1,820 papers contain the phrase open vehicle routing problem. What means this? The OVRP has not been studied at deep. This is the number of papers are too low. Only 1.42% of the topic OVRP papers written between 2000 and 2018 talks about OVRP, and only 3.12% of total production about this topic, VRP, talks about open vehicle routing problem. A literature survey presents hybrid models, but the hybrids are mainly based on metaheuristics such as taboo search, simulated annealing, particle swarm optimization, and colony optimization, genetic algorithms, among others. Basically, the subcomputing models found the uses of subcomputing to solve the additional part of the VRP, but not solve the VRP problem. The fuzzy logic was used to evaluate the uncertain factors such as traffic, accidents, lead times, disruptions, etc. But this fuzzy logic not be used to solve the routes. What is OVRP? The Open Vehicle Routing Problem, or OVRP, is a variant of VRP with the chance to end the route on a place different than the central depot. What is the advantage to finish in other place than the depot? We have several chances, such as pickup of raw materials, pickup of void tools, replacement parts, replenishment of goods, maintenance, among others. Proposal. This method is based in three stages. First, using an instance that serves as basis to generate the routes by evolutionary strategy. But what's an instance? An instance is a route that serves as benchmark and could be created with other method. In this case, the instance was created with the shortest path model or Dikstra algorithm. What is an evolutionary strategy? The evolutionary strategy is an algorithm to search a solution for a polynomial function. The solution method is based on the evolution theories of Charles Darwin and Gregor Mendel. How the evolutionary strategy works. Test an individual with others that have the same parameters or variables to get the best individual versus a function that represents the problem that needs to be optimized. The evolutionary strategy algorithms begin with the generation of vector with parent characteristics. This is an instance created to be evaluated. With the vector parent are generated the address matrix that represents a coordinate system with the location between the clients. The address matrix are converted to a vector with the address of every client. Later are generated the parent vector with a random selection from the step 2 of matrix. The population of zones are generated by recombination or mutation of the parent vector. Later, these pair of vectors are evaluated with a system type 1 singleton fuzzy. This is the second phase of the proposal. Later, the output of type 1 singleton fuzzy logic system is used as input for the following phase, where the evolutionary strategy is used again, generating the solution of the roads. This is a vector with parent roads and a vector with zones roads. Via tournament are selected the best individuals to minimizing the distance or cost between the clients. With the use of generations as stop criteria, from generation 1 to generation n, selecting the best roads to optimize the solution. Finally, the evolutionary strategy is repeated while the stop criteria are not accomplished. This is the number of generations. Return and select the best individuals again. Finally, when the number of generations are complete, the algorithm of evolutionary strategy finish. Experimentation. The experimental tests are shown in the following table to evaluate the proposal evolutionary strategy type 1 singleton fuzzy logic system open vehicle road problem. And later, these experiments are compared with the complementary test with an instance to generate a benchmark. Do not exist instance for this kind of OVRP model. We created an instance using Dikstra model or shortest path model. This is the instance created and the distance obtained are 5013.5. The computational time are 2 minutes. The experiments using evolutionary strategy type 1 singleton fuzzy logic system open vehicle road problem are follows. First test is composed by 5 individuals and 2 generations. For the second test, we have 10 individuals and 2 generations. In the third test, 20 individuals and 2 generations, and later 20 individuals and 8 generations. In the 5 tests, 50 individuals, 8 generations. For 6 tests, 100 individuals and 8 generations. And finally, for the final test, we have 300 individuals and 8 generations. Results. The experimental test showed that it's possible generating an optimal road in a few seconds. This is in less than 45 seconds for 300 individuals and 8 generations. The precision obtained is superior to 80%. This is better than the general precision obtained by neural networks or other models of optimization. In this table, show the first 2 tests. For the first test, the worst scenario showed 43% of error, and the best scenario outperformed the Dikstra algorithm in 6.6% for first test. In the second test, the worst scenario showed an error of 38.1%, and the best scenario outperformed the shortest path algorithm in 5.4%. When the results are compared with the ant colony optimization method, we have that only 2 of the 10 scenarios tested produce better results than the proposal evolutionary strategy type 1 singleton fuzzy logic systems in the first 2 tests. Also, when the results of the proposal are compared with simulated annealing, we have that all of the results of the proposal are better than simulated annealing in the 2 tests. If it's compared the proposal with the evolutionary strategy type 1 neurofuzzy system, we have that only 8 of 20 scenarios tested produce better results than the proposal, are produced the comparison between type-1 singleton fuzzy logic system and type-1 adaptive network fuzzy inference system or neurofuzzy system. The proposal outperforms the models used to compare, also outperforms the Dikstra model. When the proposal is compared with ant colony optimization, the proposed model outperforms the ant colony by 90.2%. When it's compared with simulated annealing, the proposal outperforms this model that produces an error of 91.3%. The evolutionary strategy produces, in the worst case, 20.1% of error, and in the best case, outperforms the Dikstra model in 70.4%. In contrast, the Amphis model produces an error in the worst case of 23.1% and in the best case 2.9% compared with Dikstra model. The experimental results also show that the proposed model outperformed the benchmark models as, when it's compared with Dikstra model, in 8 seconds outperforms the result in 4.2% and in 16 seconds in 7.5%. The comparison with ant colony optimization produced the same result. The proposed model outperforms the ant colony optimization by 19.2%. In comparison with simulated annealing, the produced result is similar and produces an outperform of 91.3%. When it's compared the proposed model with evolutionary strategy type 1 adaptive network fuzzy inference system, the error produced in 8 seconds are 7.7% and in 16 seconds are 13.5%. The ant colony optimization algorithm is restricted to not have more ants than clients to visit. With more ants than cities, the pheromone concentration produces a route selection that gives a local solution or non-optimal solution. The computational time spent on the solution is not relevant, in contrast with error reduction in every test of evolutionary strategy type 1 singleton fuzzy logic system. The use of 5 seconds or 50 seconds in the worst case is not a waste of time, because it is saved more than 19% than the metaheuristics and more than 2.8 than the Dikstra model or shortest path model. Thanks for your attention.